Alright, welcome everybody. This is going to be, if you're new to the channel, I make videos on calculus 1 and 2 concepts, and this is going to be my second video in Unit 2. Today I'm going to be talking about derivative rules. Okay, so this is going to include your power rule, product rule, chain rule, quotient rule, and one-steppers. Okay? And what do I mean by one-steppers? I just mean functions whose derivatives you should memorize. Okay? So, let's begin with our, you know, power rule. Okay? That's the most straightforward. So, the power rule is so you'll notice, right? All of these rules are simply, they're just simplifications of um, the process of taking a derivative, right? You could always do the whole limit as h approaches 0 of this, and you could, limit out the difference quotient, but this takes forever. It's just not worth doing because all these rules make the process so much easier. Okay, so before we even begin talking about the rules, the first thing we need to talk about is the fact that the derivative is what is known as a linear operator. Okay, so what does that mean? Well, I'll show you, right? So the derivative, right, is it's a process that you apply to functions, right? So you can think of it as a function of functions. Okay, so this is what we call an operator. So that's this piece. Okay, now what does linear mean? Well, let's see. If you take the derivative of, say, the sum of two functions, right? So say f of x plus another function, g of x. Okay, and this could also be minus, right? If you take the derivative of this, it being a linear operator means that the derivative is just going to be the sum of the derivatives, right? So in other words, the derivative of the sum is the sum of the derivatives. Or, I mean, on the other side, the derivative of the difference, right? If this was a negative, the derivative of the difference is the difference of the derivatives, okay? And it also means one other thing, that if you take the derivative of a constant times a function, then you get the constant times the derivative of that function. Okay? So this is what it means to say that the derivative is a linear operator. Okay? Now we can move on. So, power rule. The use case is really just polynomials, right? This is your go-to tool for polynomials. It makes the process so much easier. Okay? So let's say you have a polynomial, and I'm gonna make this sparkly. So the power rule basically gives you a way to break down the derivative of each term of a polynomial, right? And since the derivative is a linear operator, then by taking the derivative of each term and adding them together, you get the derivative of the sum, okay? So let me show you what I mean by that. So the power rule tells us that the derivative of, oh no, I want my sparkly back. Okay, the derivative of a function, right, x to the n, is going to be n, right? So you drop down the exponent times x to the n minus 1. So you drop down the exponent and subtract 1. Okay? So um, let's apply this, right? Say you have uh, x squared, right? The derivative of x squared, if we apply this, right, our n is 2. So we drop down the 2, we get 2 times x to the n minus 1, which is going to be 2x to the 1. Okay? Taking the derivative of x, right? This is, well, x is simply just x to the 1. So if we drop down the exponent, we get 1 times x to the 1 minus 1, or 1x to the 0. X to the 0 is just 1, right? So the derivative of x is 1, and that makes sense, right? Because the slope of the line, x, is going to be 1. If you take the derivative of a constant term, right? so let's say big C, then you get, well, this is simply the derivative of big C times x to the 0, right? Because x to the 0 is 1. So dropping down this, you get C times 0 times x to the negative 1, or 0, right? So this is our power rule, and it's going to apply for any n you put in here, okay? Now, I want you to remember that the derivative itself is a linear operator, okay? So that means if we're taking the derivative of 2x squared, right? Then this is just going to be 2 times the derivative of x squared, or 2 times 2x, or 4x, right? So this is how we sort of apply the power rule to any polynomial term, right? So say you have 7x to the 6th, okay? 7 times 6, 6 is our n, right? 7 times 6 is 56, and then we're going to subtract 1 from 6. So that's our derivative, okay? Now, so this is all we've considered so far are singular terms, all right? Now if we take a whole polynomial, right, and we try to take the derivative, well, the derivative is a linear operator. I'm going to say that a lot today, but because of that, we can simply take the derivative of each term and add them together, right? The derivative of 2x is 2 times x to the 1, which is 2x, right? The derivative of, or I'm sorry, the derivative of x squared is 2x. The derivative of 2x now is going to be 2 times 1, right? Because 2x to the 1. So 2 times 1 times x to the 1 minus 1, which is 0. So this is just going to be 2, right? And remember, the derivative of any constant term is going to be 0, right? That makes sense because think about constant terms, right? All they are, if we graph y equals c, where c is a constant, right? This is just a straight line. So this is not going to have any slope anywhere. It's going to have a slope of 0 everywhere, okay? So this is going to be 2x plus 2 plus 0, or 2x plus 2. And you see that this makes the process of taking the derivative of polynomials so much easier. And it's not just polynomials, right? Say you're taking the derivative of root x, okay? This is simply the derivative of x to the 1/2, right? So this is going to be, if we apply our power rule, n is 1/2, so it's going to be 1/2 x to, remember, n minus 1, right? So n minus 1 here is going to be 1/2 minus 1, which is negative 1/2. So this is going to be 1/2 times 1 over root x, or 1 over 2 root x, right? So the power rule basically makes taking the derivative of functions like these infinitely simpler, right? And I can go through a whole proof um, in a separate video. In fact, I'm planning to do that. So stay tuned for that if you would like to see it. Okay, so there's the power rule, right? For now, I'm